The abacus is an early calculating tool that uses beads arranged on rods to perform arithmetic operations. The abacus's design allows for efficient addition, subtraction, multiplication, and division. The abacus represents a fundamental step towards automated calculation. The Antikythera mechanism is an ancient analog computer designed to predict astronomical positions. This device accurately forecasts solar and lunar eclipses using a series of interconnected gears and dials. The mechanism demonstrates early mechanical engineering and a sophisticated understanding of celestial mechanics. The Pascaline, invented by Blaise Pascal, is a mechanical calculator that automates addition and subtraction. The Pascaline uses numbered wheels to input each digit of a calculation. Carryover mechanisms enable the Pascaline to perform complex calculations. Joseph Jacquard's loom used punch cards to automate the weaving of complex patterns. Each punch card corresponded to a specific row in the woven design. The Jacquard loom represents an early form of programmable automation. Charles Babbage's analytical engine was a conceptual general-purpose computer. The analytical engine included an arithmetic logic unit, control flow, and memory. Though never fully built, the analytical engine laid the groundwork for modern computer architecture. Ada Lovelace developed an algorithm for the analytical engine to calculate Bernoulli numbers. This algorithm is recognized as the first computer program. Lovelace's notes highlighted the potential for computers beyond mere calculation. The Turing machine is a theoretical model of computation that defines the limits of what computers can compute. The machine uses a tape and a set of rules to simulate any algorithm. The Turing machine forms the basis of modern computer science. The Z3 was an electromechanical computer that used relays to perform binary arithmetic. As the first working programmable computer, the Z3 demonstrated the feasibility of automated computation. The Z3's design validated the concept of automated computation and paved the way for future computer development. The ENIAC, the first general-purpose electronic computer, occupied an entire room. ENIAC utilized vacuum tubes to perform calculations. ENIAC revolutionized scientific computing by performing complex calculations much faster than its predecessors. Transistors replaced vacuum tubes, leading to smaller, faster, and more reliable computers. The transition from vacuum tubes to transistors marked a significant advancement in computer technology. The adoption of transistors paved the way for computer miniaturization. In the 1950s, IBM introduced the first hard disk drive, revolutionizing data storage capabilities. The hard disk drive utilized magnetic platters to store vast amounts of information. Read-write heads enabled quick access to store data on the magnetic platters. ARPANET, the precursor to the internet, connected multiple computers, enabling data sharing and communication. Packet switching facilitates the division of data into packets for efficient transmission across the network. TCP/IP protocols ensure reliable network communication by establishing standards for data transmission and reception. In 1971, Intel introduced the 4004, the first microprocessor. The 4004 integrated multiple components onto a single chip, a revolutionary advancement. This invention ignited the computer revolution, leading to smaller and more powerful computers. In 1976, Steve Jobs and Steve Wozniak assembled the Apple I in a garage. The Apple I was one of the first personal computers. Its user-friendly design and accessibility made the Apple I popular among hobbyists. In 1981, IBM released the IBM PC, which popularized personal computers. The IBM PC's open architecture facilitated compatibility with third-party software. Open architecture and software compatibility drove the widespread adoption of the IBM PC. The Macintosh introduced a graphical user interface, replacing command line interfaces with icons and windows. The integration of a mouse made computer interaction more direct and accessible for non-technical users. The Macintosh aimed to make computers more intuitive and accessible to a broader audience. In the 1990s, Tim Berners-Lee invented the World Wide Web at CERN. The World Wide Web enabled global information sharing through hypertext and the Internet. URLs, HTML, and HTTP protocols were created to facilitate web page creation and access. In the 1990s, personal computers became commonplace in households, revolutionizing work, communication, and information access. The widespread adoption of the Windows operating system significantly contributed to the dominance of the PC. Personal computers transformed how individuals create documents, connect with others, and explore digital content. Laptops, tablets, and smartphones represent the evolution of portable computing devices. Miniaturization enables the integration of powerful computing capabilities into compact mobile devices. Wireless technologies facilitate mobile computing and communication by eliminating physical connections. Google, Facebook, YouTube, and Amazon have transformed daily life through their online services. Search engines, social media, video sharing, and e-commerce have become integral parts of modern society. These platforms have redefined how individuals access information, connect with others, and conduct transactions. Cloud computing enables users to access computing resources and data via the internet. Virtualization allows for the creation of multiple virtual machines on a single physical server. Distributed computing provides scalable and on-demand services by utilizing multiple, interconnected computers. The 2010s marked the rise of artificial intelligence and machine learning. Virtual assistants like Siri and Alexa emerged, demonstrating practical AI applications. Algorithms learn from data to perform tasks such as speech recognition and natural language processing. AI models like ChatGPT are transforming work, education, and creative processes through natural language generation. These AI models provide assistance in various tasks, including writing, coding, and problem solving. Natural language generation enables AI to interact with users in a human-like manner, simplifying complex tasks. Quantum computing is under development to address complex problems beyond the capabilities of classical computers. Qubits, unlike classical bits, can exist in multiple states simultaneously, enabling parallel computation. Quantum algorithms leverage quantum mechanics to perform computations more efficiently than classical algorithms for certain problems. Devices are now integrated into various aspects of daily life, including cars, homes, and wearable technology. The Internet of Things, IoT, connects everyday objects, enabling smarter and more connected environments. IoT facilitates enhanced automation and data exchange, leading to more efficient and responsive systems.